Hi everyone, welcome to the Art of the Possible series. I'm Nihali Niyogi and I'm a Principal Cloud Solution Architect at Microsoft focused on advanced networking. Today's topic is NVA Network Virtual Appliance in AVS using the NSX stack. This video is part of a broader AVS series, so if you would like to learn more about how to build the lab, be sure to check out our other videos. With that, I would like to welcome my guest for today's session, Victor Sandoval, who is an AVS and NSX guru. And personally, Victor, I have learned a lot from you over the years and truly admire your passion for networking and being available to bounce off ideas. With that, I'd like Victor to introduce yourself.
Yeah, hi Nihali. Hello everybody. My name is Victor Sandoval. I'm a Principal Partner Solutions Architect, just like Nihali, and I focused on cloud and infrastructure, but really my passion has always been networking. Prior to that, I worked for 13 years at VMware, in which I focused on all things cloud and all things networking. So Nihali, thank you for having me here. Really appreciate it.
Of course, my pleasure. Thanks, Victor. So picking up where we left off, in our previous videos, we showed you this hybrid cloud architecture with top half being Azure, site-to-site connected branch, ExpressRoute connected branch, and AVS. We showed a workload segment and all the flows. All the flows are color-coded, orange being inbound from internet, blue being access to vCenter, pink AVS to Azure, purple flow being through Global Reach ER to ER, and green flow being internet bound from the workload segment. And remember that this is with the default SNAT setting. So the portal setting that we used was the connect using SNAT. So all of this, if you would like to check it out, you be sure to check it out in the first video. So one of the questions that come up when you have an AVS architecture is, where does the inspection happen? Where does the firewalling happen? So that's where I have listed all of the scenarios in one layer. So I'm going to light up a very busy layer. So here I have listed all of the scenarios and they are numbered. So what these numbers show is where the inspection is happening. So let's go through this one by one. So with scenario number 1, the inspection is happening on-prem. So the firewall is on-prem. In scenario number 2, the inspection is happening in vWAN. So we have a firewall with routing intent enabled, and the vWAN advertises the 00 route. And then we have NVA in Azure, so we have the NVA ARS combination, and default route would be coming from Azure. And likewise, in number 1, the default route is coming from on-prem. And for scenario number 4, we have a deep dive session planned out with Victor where we will show you how to insert an NVA within NSX. And then number 5, we will not be covering number 5. This is the transit VNet design, but we will not be covering that in this video. And lastly, I want to show you something that's common between 1, 3, and 2. So if you look at the flows, what's common between the 3 scenarios is that either on-prem would be advertising the default route, or the ARS NVA combination would be advertising this default route, or in case of vWAN, we would be getting default route from vWAN. Of course, not all of them are active at the same time, but just wanted to show you what's common. And we will be, in the later half of the video, we will be showing you end-to-end ARS NVA combination for advertising the default route. And 1 and 2 would be very similar. And lastly, just to kind of show you the flows in case of number 4, the inbound and outbound will all be happening on the AVS side. And one more important point to note is that for scenario number 1, 2, and 3, we would be using this toggle, so accepting default route from Azure. And for scenario number 4, we will show you both of these options. Okay. With that, note that this video it does build up on top of my previous video where we do a lab build out, show all of the NSX concepts. So be sure to check out some segments of that as it lays the foundation for this video. And lastly, I want to share the documentation, the Azure documentation that covers all the scenarios. So I will put this link in the description below, but these are all the different architectures. Of course, we'd be using layers to simplify the flows and the understanding. First video. So today's topic is around NVA or inspection capabilities within AVS. So let's start with some of the native functionality. In NSX, there is a construct of distributed firewall. And Victor, I'll let you talk through what can we do with distributed firewall? What are some of the limitations and use cases?
Yeah. So when we talk about distributed firewall, really you have to think about a firewall living inside of each virtual machine, and don't think about it as an agent that's living at the operating system. This is living in the kernel space inside of the ESXi host. So every time a packet is being sent in or out of that particular network interface card, before it touches the port group, it's actually being inspected by the ESXi kernel. So in essence, each virtual machines has its own firewall and it moves with that virtual machine. So if a host happens to migrate this Photon VM or Photon VM number 2 from host 1 to host X, that policy is going to be moved with it, right? And the benefits about doing this is that we can create security policies a lot more cleanly. We don't have to just use IP space to define our security policies. We can use things like virtual machine names, operating systems, or even we can create our own tags. And also the added benefit about this is that as we add more hosts into our vSphere cluster, you have more compute power available to you for your distributed firewall. So you can add more and more rules, and you're not limited to a single network appliance. So that's pretty much in a nutshell what distributed firewall is, and we can pretty much segment any type of flow that we want. We can segment two virtual machines that are on the same subnet. We can segment virtual machines across multiple subnets, and we can also segment going north and south or east and west, hence the term microsegmentation.
So is the term microsegmentation, Victor, when you have it between the two VMs?
Yep.
So mostly for east-west, and for north-south, it is done at the tier 1 level?
So you can do it at the tier 1, but there's nothing that stops you on the distributed firewall from making policies that are also affect north and south.
I see. So microsegmentation you could do for north-south as well.
Correct.
Got it. And so do we support, so when you put a firewall on tier 1, is that considered distributed firewall, or is there a different term for it?
That's just an edge firewall. So it's just you're only going to be able to isolate north and south traffic going in and out of the tier 1 is not really a microsegmentation or distributed firewall. Distributed firewall is solely on the virtual machine.
Got it. And so do we support this edge firewall in AVS?
We do. Yeah, we do. So, but at least from my experience, most customers that are using distributed firewall, they just use distributed firewall for everything, and they just do not use the edge, right? Because it's just it's a much more powerful tool to just use the distributed firewall.
I see. So this is the edge firewall, and this can be the DFW can be used for north, south,
East and west.
and east, west. Got it. Okay, good stuff. And they're all stateful.
Correct.
And what would be, in your experience, what use case, like what is the scenario where the customers would use this, um, as opposed to sort of using it with like an NVA, or is there limitations to this in AVS?
There's not really a limitation per se. You can write policies the same way that you would. You can also do deep packet inspection on NSX. I guess really the limitation will be is that NSX lives within the confines of a virtual environment, right? It lives specifically in the confines of a VMware virtual environment where NSX is installed. Right? If you wanted to go, for example, on a Azure native environment and have NSX inspect traffic on Azure native, it can't do that, right? And that's where the NVA
It
comes in.
cannot.
It cannot do that, right? So
Hmm.
it can only really control stuff within its VMware environment. Now, NSX does have the ability, like if, for example, let's say I have 4 VMware environments and each one of them has multiple NSX instances, I can combine them and have a single control plane that manages all NSX environments and push policies across all my 4 VMware environments or all 4 AVS environments. But the limitation still resides within that VMware and NSX layer, right? So if I have a physical workload and I want to do distributed firewall, or I have things on KVM, or I have them on Amazon or Azure, right? Now I'm getting like, okay, how do I manage not only my data center, but how do I manage my policies across my entire environment? So you start to get with customers that are saying, I have a 4,000 device management for Palo Alto. I have 4,000 NVAs with Palo Alto
Hmm.
appliances, and I use Panorama to manage all of them, right? I don't want to go and manage another firewall service for just NSX. And that's where you get to that limitation. That's where a lot of customers, instead of using NSX because they don't want to manage another firewall, they go ahead and deploy an NVA. In this case, in the context of this conversation, they'll deploy a Palo Alto appliance inside of AVS.
Got it. Yeah, no, that's a great explanation. So again, it boils down to like what we've seen, skilling, and also a vendor dependency and operational overhead of maintaining the policy, really, right?
Mm-hmm.
Perfect. So that sets it up perfectly for our next scenario and the main topic for today, which is using NVAs in AVS. So let me hide this workload segment and we'll show you the plumbing. How do you go about inserting an NVA in NSX? So what we've done, and if you remember the IPs from before, we're going to, for NVAs, we have an inside segment and outside segment. Notice the third octet being 31 and 32. And so we'll create these two segments. We'll show you how to do this in NSX, put the NVA in have legs in both the segments. And kind of for the benefit of our viewers that are not familiar with the construct of segment, I have like a real simple kind of vision of NSX segment as thinking of it as a layer 2 segment, right? So under the hood, it's just a layer 2 segments.
Yeah, so yeah, that's basically what it is. An NSX segment is just a layer 2 network.
Right, and then just kind of from a simple design perspective, this NVA kind of plumbs into outside segment and inside segment, just how you would do it for a firewall in the real, if this was a real layer 2 switch. So again, it's an NSX segment, doing layer 2 over layer 3, but I did want to introduce that concept of segment. Then the flows would look something like this. And remember, we still have the portal setting of SNAT to start with, and the outbound flow would go like this. Inbound coming in, we would still come in through Azure. I should have an app gateway here. I'll fix that. We showed you that in part one. And then flows between Azure and AVS would go through this NVA right here. The vCenter one doesn't go through that. And then global reach. So if you had an ExpressRoute connected branch, that's what it will flow through. And this is the new construct for today's discussion that I want to throw out there, just because we don't have a global reach. So what I've done is I have a VPN connected branch. And remember that anytime you want transit between a VPN connected branch and AVS, which is an express route connected branch, you need a route server. Okay, so this let me quickly show you this VPN-ER Transit in the portal, how that is set up. So here I am under hybrid connectivity route server, and I have a route server set up. And if you notice in the route server, the most important setting is I have branch to branch toggle enabled. And if you look at the overview screen, it is in the hub VNet, and you need a special subnet called route server subnet pre-created before you deploy this. And then, of course, I have a VPN gateway. So coming back over here, I have a VPN gateway here, and I have a VPN setup as well. Let me show you the VPN configuration. And here I have, if I go under connections, I have a connection set up to on-prem, and I have a simulated on-prem, and I have an ASAV on the other end. And that ASAV, if we look at that, it's this local network gateway. Okay, so this is my local network gateway. And if you look at the settings over there, my networks are 10, 10, 2. Okay, so that's my local network gateway. And let's quickly grab the IP address of the VPN gateway, and I can show you how my tunnel is set up on the other end. So here our VPN gateway IP is 181, and I am on the ASAV, and you can see that my tunnel destination is 4.153.16.181, which is the IP address of our VPN gateway. And if I show you the VPN, the SAs, the security associations, you can see that I have bidirectional traffic flowing with the NCAPs and DCAPs packet incrementing. And on the bottom, you could see that I have a VM. I've called it inside VM. We will be using this VM throughout to ping, and the IP of that VM is 10.10.2.5. So this is behind the firewall. Back to the drawing board. This is that VM 10.10.2.5, and we will be using that using the route server. So just be aware of that. And so all of these flows will then be flowing through the NVA. So this is what we will demo today. Victor, anything you want to add here in terms of, before we kind of jump on the NSX manager?
No, I think one thing that we're going to find out is that we're going to be doing static routing from that tier 1 down to that NVA. And also from the NVA back to the tier 1. So we're going to have to add those static routes because again, we're stepping outside of the control plane of that tier 1. So it's not going to be aware that there's networks southbound of that NVA. And we can show this as we build it out.
Good point. Yeah, and you just reminded me, just also notice the IP addressing interface for the NVA. We're going to make it 31.254 and 254 on both sides. 32.254 will continue to keep tier 1 to be 31.1.
Okay.
Perfect. All right. So with that, we'll build this out. Let's go jump on the NSX Manager, and vCenter. So continuing on where we left off, we still have that workload VM. Victor, maybe we just do a quick sanity check, just making sure everything still works from our previous lab. So, so this one still works, and we can ping something in Azure, so that all still works. And we'll keep this as is. So this is in Azure, and this is across the VPN that I mentioned. So this is across the VPN. Okay, so this is using the VPN-ER Transit using ARS. Okay, so this is our starting point. Um, we can start to create segments, Victor, if you like, if you want to drive, doesn't matter. We'll start with outside, inside, and I have all the IPs already carved up. So we'll start with creating segments.
Yeah. So you can drive. You know the IP space, so we
Okay,
can just
sure.
go. Let's.
There, there.
I say we start from top to bottom, right? So let's do the outside segment,
So sure. It's my
and and that should be connected based on our drawing to the tier one that's already been deployed. And the IP for
eh,
that will, I think, is 31. That one.
yeah. So
10.100. Yeah, 31. That one.
okay.
And then save.
Do we want to add the
We don't
DHCP?
we don't need the HTTP because this is going to be a point-to-point network, right, between the NVA and the tier one. Oh,
Yeah, so what I thought was
yeah.
initially we set it up with DHCP and then we'll give NVAs a static IP, only because when I install the NVA, it does go out and try to reach for the,
But like, okay, so if we go to your drawing real quick,
sure.
that 31.1 and talking to that 10.131.254, the only connection that we're gonna have is 2 on that particular segment, so we don't need a /24. We can
Oh,
make
we
it a
could make it a /30.
yeah, we can make it a point-to-point network
Yeah,
just to make it more clean,
okay.
and then just avoid DHCPs because there's no need at that point.
So that's a good point, Victor. So you're saying you want to make this a /30, and so we will make this /.2 then, right?
Mm-hmm.
Perfect. Makes sense. You are a true point to network engineer. Point to point has to be /30. Couldn't agree more. Good catch. All right. So I get your point. So we will just keep this and then no need to set up DHCP. We'll give a static IP.
Let's change the CIDR. Right now it's on 24.
Ooh, yeah,
Yeah.
good catch. All right. So save here and
Do the NVA. And then we'll do let's go in order of operations. Look, so you go to your drawing,
yeah,
southbound of that segment
you
is the
understand.
NVA.
Sure. So you want to go top down on this design. So we just created this. Now we want to create the NVA, right?
Correct.
Sure. Let's do that. So here we are on the, so we'll just, on the vCenter side, we'll just say create new virtual machine. And we already have that ISO downloaded and in the data store. So let's call this Linux NVA 01.
Give this one 4. Let's give
Yeah.
it 8 gigs of memory.
Okay. So Victor, here, if you pause, go back over there. I wanted to pause for two things. One is the two important callouts on the screen. Yeah, let's pick the outside segment here, right?
Yep.
Yeah.
One segment.
And then for the benefit of you of your viewers that don't come from VMware background, is that we can choose the
The
ISO.
ISO.
Yeah.
Yeah, so imagine a virtual machine having a CD-ROM.
Mm-hmm.
That takes you back, right? And
Mm-hmm.
what we're doing right now is putting that CD, that ISO file, into that CD-ROM or the CD drive,
And
right?
connect on power
And
on
then
is the
connect that
important
power
setting.
on.
And
Yeah.
before you hit, oh,
Oh,
okay,
go
no
ahead.
worries. Yeah, before we go there, expand the new CD DVD drive.
Yep.
Yeah, and you can then see the full. So these are the two important things: the network and connect on power on this screen. Awesome. Yeah, let's go ahead and finish. We can start the VM. Are you able to control this screen,
Yep.
Victor? Okay,
I
good.
am.
So this is where it will try to get an IP, but we don't have a DHCP server, so we would have to go and add that manually, right?
That's right. Yeah.
Should I control C out of this?
There
Okay,
we go.
there we go. Let me know if you can control it. If not, I
Sure.
can.
Let's do English. What do you think?
Sure. You're funny.
Ubuntu server. All right.
Oh, wait, this is
Uh,
the key
uh,
point. Okay,
yeah.
so
Did you want to do minimal installation or you want to do
no,
do you
that's
want
perfect.
to okay,
Minimal
okay.
is good. Yeah, so this is where we actually go ahead and punch in the IP, right?
Yeah. So let's go. I think my tabs. Here we go. All right. And
I'll help you. Oh, yeah, go
yeah, go
ahead.
ahead. Go ahead because my tabs are not working on my side.
Okay, so IPv4. I think it's the spacebar for me. Oops. Manual. Okay, so it's going to be 10.100.31.0/30 and 10.100.31.2 and 10.100. Oh, so one is already on the,
On the tier 1.
yeah.
This is the first time I ever had to define a subnet on an operating system. I don't think I remember doing this.
Hmm.
Typically, it does it by yourself when you put in the CIDR.
Yeah.
But yeah,
So this looks good, right? I think this is 10.100.0.92, but we'll see. Do you want me to double check just in case? So this comes from our previous
you're drawing. Yeah.
drawing. The DNS comes from, let me just quickly show where the DNS is coming from. 10.100.0.192. Okay, so I think we're good to go. Tab save. Um,
Yep. And done.
done. Should I, is there another save or close? Okay, good. Looks good. Done. Okay, do you want to continue or should I finish it?
Go ahead. Yeah. So use the entire disk and done. And done. Yeah. Continue.
Okay.
Yeah, we can skip it.
I'd like to install SSH server just so we can test some connectivity.
Okay.
And that's it.
And we checked that it has access to the internet because I think it was able to get the latest update from the mirror.
Mhm. And that's using that SNAT setting.
Yeah, we can double check it once once it reboots.
Yeah.
Yep.
And we validated that at the beginning on this other VM, the Photon OVA, that it had all the connectivity. But this is through the new segment. There, it's done. So let's go ahead and hit reboot now. Oh, yes, we have to disconnect
All right,
the.
it will do it. It will do it by itself. We're good.
I tested
So
it the other day and I had to manually do it, but let's see.
yeah, if you go to the VM real
Yeah,
quick.
right here.
Hmm. I typically don't have to do that, but let's do it.
Oh, it's not
Yeah,
connected.
yeah.
Or hit enter. It says please remove and then hit enter. Okay, yeah, so we just have to hit enter.
There you go.
Yeah, that will do it. So we have the right
IP.
IP, and then we should be able to do. Yeah, so we are reaching out and we should be able to ping something in Azure, right? Oh, sorry, it was 5. Good, and we should be able to ping.
The default
Uh,
gateway.
let's just double check. Yeah. Or uh, default gateway. Yes, let's ping the default IP route show. So the default gateway is 10.100.31.1. Perfect.
Yep. So
And one
that's
last test is the pinging across from the VPN, and that should work as well. Perfect. All right. So do you want to connect the second segment then
sure. Let's
with
do
the
that.
way kind of top down going? So far we did the outside segment and deployed the NVA, put it in this outside. So let's create the inside segment. So did you want to drive in the NSX side?
Well, one thing that I think that we forgot is that our network appliance only has one NIC.
Ooh, ooh, yes, we need to do that first.
Let's give
But
it another
maybe
put
we
it
do
in.
the segment and then the nick so we can place the nick, or can
That's
you?
right. Yes, right. Yeah, no, no, that makes perfect sense.
Yeah,
So let's add it.
inside dash segment.
This is the inside.
Yeah,
Is that what we have it
yeah,
inside?
inside. That's what I called it. Inside dash segment, and it's 10
Very
dot.
very
Yeah.
important. It's not going to be connected to a gateway, right? Because we're not going. This is going to be isolated in essence. So we're going to put none, and we don't have to put in the gateway on this. So we can just go ahead and select save.
Mm-hmm.
We're not going to
It's a
make
good point.
changes to it. So now we should be able to add our interface to our existing VM. So hopefully it lets me do this powered on, but we're probably going to have to restart it. Network adapter. So here we put it on the inside segment.
What about the IP for that? We would have to put it manually then.
Correct.
Okay.
Inside segment. Okay. And if I'm not mistaken, Windows is probably not gonna like it. Linux is not gonna like it. You're gonna have to restart it. So yeah, go ahead.
I don't know if we got the IP. Yeah, we got the second NIC, but it
Oh,
doesn't.
okay. Yeah. So now we can have to do and statically assign it on the gateway. So will be a /24, right, for the second subnet for the second NIC, and it will be the
Yes.
gateway. So it will be. Let me see. What's our drawing say? 10.132.254.
Yes, so it will be 254. So if you want, I think an easier way to do this is, let me see if I can SSH in. It just drop the config. It's easier to do it rather than console. So I'm on the VM across from the VPN, just so that we could SSH in. So I'm on
Okay.
this VM and SSHing into this one. Okay,
Awesome.
so what we have to do, so we'll just do b sudo -s, just that way I don't have to type the password. Okay, and so we go to cd net plan, and we just edit this cloud, and we just add the second NIC here. So let's see what the right config should look like. So we only have the 33 in here, right? So we just add a thing for 32. And note that that side would not have the default gateway, right?
Right.
So we say DHCP false, address 32.54, and then I don't
Is that
even think,
is that the right name? ENS34.
let's double check. Oh, it's ENS 35, good catch. So then we can do net plan apply. Okay, so that is indeed 32.254.
Okay.
So now we have the NVA. Let's deploy another VM in the inside segment, Victor.
Okay. Let's do that.
Okay.
So.
And we'll
Let's
call it inside VM, maybe.
call it inside.
Yeah.
You want to do? Do you want to keep recording?
Yeah.
We'll speed it up.
And we want to pick here we want to pick the inside segment.
Yep.
Let's pick the ISO first.
No,
Images
one file. There you go.
and the inside segment. So here the controls C trick again.
Mhm.
Okay, so we can quickly go through this one, Victor, and just kind of pause at the IP screen, right? Oh, there. Looks good. 32.254 is our NVA.
Perfect. And this won't work because we don't have the routing in place yet. So we can just go ahead and do done.
Okay.
And then, yeah, continue. Yeah, yeah. So let's go ahead and finish with the LVM.
Mm-hmm. Mm-hmm.
Yep. I'm not sure if this will work unless SSH is on the ISO. We can try it.
No, we didn't. We don't need inbound SSH on that one.
We can test it out right now. So like right now, it's gonna fail, and the reason why it's gonna fail is because if you look at that web VM that we deployed, right, it has a route to go to the NVA, but if you look at the very top, the Corp Tier 1, it knows about 10.100.31, the point-to-point subnet, but it doesn't know anything that we define southbound of that NVA because it's not participated in dynamic routing, right?
So it
So
doesn't know about the 10.132 network.
exactly. So we're gonna have to go to the Tier 1 and give it a static route,
Mm-hmm.
and that should fix our problems. So let's,
Also, I think at
yeah,
the NVA level, Victor, this NVA Ubuntu out of the box doesn't have IP forwarding enabled. So we
okay,
will also have to do that. Just strictly from just making this a true NVA, we need the IP forwarding enabled. So we can do that as well. So should we do that instead of waiting over here?
yeah,
Maybe
yeah,
that would
I
be
think,
the
yeah, I think we're gonna be stuck here. So let's go to that. Let's do the NSX side first. Let's go
okay.
top.
So you go ahead. Yeah, you
Yeah.
can control that one. Yeah.
So if we go to the Tier 1, and if we edit, we're gonna go ahead and do our advertisement. Let's see. Additional settings. Going down memory range. Set
Mm-hmm.
advertisement rules.
Static route. See at the bottom. Way at the
Keep seeing it.
bottom.
Sorry.
Yeah, right here.
Oh, static routes. Okay, yeah. Sorry. So yeah, let's set the static route.
So 10.100.32.0. So you can call it inside segment 32
32 dot
0/24,
24, and the next
and
hop
then
will be
it
the
in the firewall. So 10.100.31.254. So because tier one is on that segment,
no. It will be the 2.
31.2. You're absolutely right. Yeah,
Yeah,
my
yeah, yeah,
diagram still
yeah,
says 254. Yeah, good
yeah.
point.
So because it's 1, right? So the Tier 1 it's dot 1,
Mhm.
and this one will be dot 2. Okay,
Yeah,
so
no,
edit.
my original plan had 254, so I hadn't updated my diagram on. Okay,
Okay.
perfect. So we can call this inside segment, route to inside segment. Perfect.
And now this should be advertised on the Azure side. So I'm not
As
sure if you
well.
want. Yeah, I'm not sure if you want to show that.
Yeah, let's do that. So on the Azure side, if we are here, if we refresh the effective routes, so we should see 10.100. Let me just search for the specific thing. 10.100.32. Yeah, that's it.
Yep. Okay. Um, so now we can do two things. First, I think we have to go to the appliance and
Mm-hmm.
set up the relay.
IP forwarding.
Yeah, IP forwarding. Sorry.
Yeah, so let me do that. And there are a couple different ways to do it, but I think the best is using that at C sysctl dot. we have this guy. We uncomment this IP forward, and then we do sys. And then we can verify cat prox. Yeah, perfect. Let's take a quick look here. It looks like it is moving forward, so we'll let this finish. What do you think? Yeah, it's now moving forward, the inside web.
Okay.
And if we really want to be geeky, we should start seeing traffic on this side over here, like on this side. Host 10.100.32.10. Start seeing
Okay.
traffic. Yeah, perfect. Awesome. So this should have, yeah, so this is still spinning. I'll pause the video here.
Like the web VM finished its thing, so let's go ahead and reboot.
Okay. Did you also want to request control? I see you have lost control, so
Sure. There you go.
nothing like watching our faces fly by the
With the cursors, that's a pretty cool
yeah,
feature.
yeah. So we have the IP header and IP route should show us that our default route is 32.254. So first things first, we'll just ping the default route. Then let me just bring this all the way up at the top. So this works, right? Curl ifconfig.me should egress, so that works. Does the Azure side work? 16.1.5 Azure works, and then 10.2.5 was across the VPN. So we have all of these connectivity coming back to the drawing board working, Victor. So with the portal setting, we have the outbound working. Uh, we haven't tested inbound yet, but to Azure working, and then we don't have global reach, but we did test the pinging to this blue across the VPN. Anything you want to add on this one?
No, so as you can see, it can get a little bit troublesome, right? Like if I was thinking about day two operations, if I'm going to be adding 6, 7, 8 subnets on the bottom, right?
Yes.
I will have to add another static route on the tier one. So just keep in mind, if you're going to do something like this, SuperNet is probably your best friend, right? So just do one static route that's super netted so that you don't have to do individual static routes.
For all the downstream, the VMs that are downstream of the NVA.
Correct. Yeah.
Over right on this tier one. Yeah, agree. Yeah. So there's a lot of manual sort of, yeah, day two work that we have to do.
Yeah. SuperNet should make that easy, right? You just do one entry and you're done. Be done with it. You just got to make sure that you architect your IP space correctly.
Yep, got it. So again, like just to kind of complete this was the very simple design just with single NVA and single NVA, single tier one. Of course, you know, in the real world, you would want to have high availability for the NVAs as well. So we got all the flows working, including all of these flows working, including the VPN ER. And we haven't tested this one, but we did this in the previous video. So it shouldn't change. This VM would still be routable and can be the backend to the app gateway. Right, Victor?
Yep, correct.
Perfect. So now let's go on to the next scenario where we will change this from connect using SNAT to using public IP on the NSX Edge. And we'll talk through this design, but let's go ahead and toggle this because it takes some time. So when that's happening, we'll talk about that scenario. What do you think? Should we go ahead and toggle it
Sure.
first? Okay.
Hmm.
So again, now we are moving from this to this, this design. So Victor, you want to talk about this and how maybe we first just go ahead and add this and then we talk about it. So public IP range, and we can pick, we'll just pick like /29 for now. With 8 addresses, hit create, and then
Yep.
we can confirm and save. It is disruptive, so if you're doing this, be sure to do it in a maintenance window, right? It will cause disruption to your internet
It
connectivity.
will. It will. Yeah. So just a quick recap on what this is doing.
Mm-hmm.
With the SNAT, what happens is that basically any traffic going to the internet is being snatted by Azure. Some customers want more predictability of where the traffic is egressing from, so they want to see that public IP address, and with an SNAT, that's very difficult to do. So what they do is they choose this third option where Azure gives you IP spaces. In this case, we ask for /29, which just gives us 8 public IPs. And now you can bring those public IPs into NSX appliances. So you can bring it to the tier 1, or you can bring it directly into the NVA. And what this allows you is that predictability of knowing for exactly from which public IP your traffic is egressing from, and it also gives you more leniency on where do you want your traffic to flow. Maybe you want one IP to be part of one NVA appliance, and maybe another IP be used for other purposes. Right, so that's really comes down into your requirements for this lab. I think, Holly, we will probably just use one public IP and assign it to that NVA, and maybe that will be the next step. What do you think?
Yeah, perfect. Maybe we do this just to mimic a real world kind of thing. Maybe one IP for egress and one for DNAT.
Sounds good.
Inbound. Okay,
Mm-hmm.
perfect. Yeah, so just to visualize what Victor just mentioned is, so portal setting is now switched to NSX, and we are going to envision the inbound and outbound flows. So this green flow will set it up so that it uses one of the IPs now on the tier 1, right? So Victor, help me fix this flow. So does this also traverse tier 0 or directly goes from tier 1?
No, it all has to go through tier 0.
Yes.
But for for I think for illustration purposes, it's easier to visualize this as if it's just going directly out of the tier 1.
Because the IPs that we got and the ones that we are configuring DNAT, SNAT on is going to be on tier 1, right?
Correct. Yes.
Okay. So the green flow is egress, for which we will set up the SNAT, and then just to complete the flows, um, this is the key concept. First time I did it, that once you egress, so once you start moving all your traffic through the tier 1 towards in this direction, you have to no-NAT the private traffic so that the private traffic doesn't get natted, and then these flows, the ER to ER, the pink flow continues to work, and the Azure flow continues to work. So all of the RFC 1918 traffic, we would have to no-NAT. Any comments on that, Victor?
No, no, that's exactly right.
Yeah, so all these 3 flows, we would put it in no-NAT. So yeah, so let's go ahead and set this up. So what should we test first? Outbound? Should we set up outbound end-to-end first?
Sure, let's do outbound. I think the setting should have taken effect by now.
Okay, so let's go check. Still creating a. So we pause the video, and as you can see, our NSX public IP range is now provisioned. So let's copy this range and we'll jump on the NSX manager and we will set up the outbound NAT. So here we'll go on to the networking tab and then NAT. And the most important thing is be sure that you are on T1, and let's go ahead and add an outbound rule. We'll call it outbound SNAT, call this SNAT, and we will copy this range. Of course, we will just use the first IP. Okay, so with that, and then we can leave the source as any. For now, let's set the priority to be 1. And we'll discuss priority a little bit more in depth a little bit later. But for now, let's set up the SNAT and then use our first IP and hit save. So let's refresh the screen over here, make sure it's a success, and then let's jump on to the web VM. If you remember, before we did curl ifconfig.me and we got the IP address of 2213 to 10.13, and run the curl command again. And sure enough, we get the 200.128. Now let's go ahead and try to ping to something in Azure. And this ping is failing. And why is that, right? So remember when we were doing the envisioning, I had mentioned that we have to add the no-NAT rule. So for right now, kind of coming back to the drawing board, we can reach outbound, right? We can reach outbound via NSX, the blue flow. But when we try to reach something in Azure, this pink flow is failing. That is because we need to no-NAT the Azure segments, and likewise we need to no-NAT the VPN segments as well. So let's go ahead and do that. So that one's failing, and then the 10.10.2.5 will fail as well. So let's fix that. So if we go back to the NSX manager, and we need to add the no-NAT rule. So for the no-NAT rule, we'll say add rule. We'll call it no-NAT private IP, and we'll call it no SNAT. Okay, and then here we can say the source IP of 10.0.0/8. So let's add the Azure range, the 172.16.1.0/24, and here the priority becomes important. Here, the lower the priority, the better it is. So the higher the precedence is. So let's make this 1 and save. And let's go ahead and change this one to 2. Okay. And let's make sure we'll refresh everything. Let's make sure everything is good. And then let's go ahead and ping something in Azure. Sure enough, it pings. This will still not work. So let's go ahead and fix that as well. So we'll add another rule. I'm not sure if we can update this one. We can try, or we can add another rule. So let's go ahead and add another NAT rule. We'll call this no-NAT for VPN, and we'll say no SNAT 0/8, and we'll put the destination as 10.0.10.10.2.0/24. Okay, so we'll be more specific. And again, like I mentioned, lower the priority, the better it is. So we'll give this a priority of 1 and we'll hit save. And there we have two no SNAT rules, and kind of looking at the priority. Let's fix the priority here as well. So we'll make this 3. Save, and we will make, we have this priority as 3, so we will make the first one. We have that priority of 1, and then let's see what the priority on this is. So we'll put this as 2. We'll go ahead and hit save. I'm not sure if it will let us keep the same priority, but for now we have 1, 2, and 3, and there is a possibility that we can combine these two. I haven't quite figured it out how to combine these two, but for now the idea is that we can NO-NAT. So let's go ahead and test it again. So we can ping 2.5 and we can ping something in Azure, and of course we should be able to still run our ifconfig command. So sure enough, let me clear the screen so you could see it. And sure enough, we can egress from Azure using one of the NSX IPs. So now let's set up the DNAT. So for that, again, we go into the NSX manager. We'll click on the NAT screen and be sure to use the T1, and then we will set up a DNAT. So we'll say DNAT to VM. Or we can even call it inbound DNAT to VM. We'll say source any, destination is where let's grab the next available IP from the NSX IP space that we got, and we'll go ahead and put that one over here. We'll make the one, we'll use 129/32, and we will put the translated IP as 10.100.32.10, and we'll have something over here ready to go. So let's say and let's go ahead and run a simple Python based web server. So now that it's answering, we will point our translated IP to 32.10. Okay, so with that DNAT tier 1, we have all the checks. And now that we have this, we should be able to get to 129 from outside. So let's test that. In fact, before we turn on the server, let's just make sure that we have something in here. So let me make sure I have an index.html file here. We don't, so let's go ahead and touch an index.html file. And we'll call it web VM. Let's start up the server again. And let's see if we can hit this IP from outside. So let me bring my other window over here and let's try to hit this IP from here. And sure enough, we get the web VM. So inbound is now working. So kind of coming back to the drawing board. We got all the flows working. So we tested outbound, the green flow using SNAT, the inbound, the blue flow using DNAT, and then we also tested NO-NAT for Azure, and we tested NO-NAT for VPN traffic as well. So all of our flows are now working. And if you did want to test the inbound through from Azure, let's go ahead and change our app gateway setting. So if you remember, so here we are on our app gateway. If you remember from before in the previous video, we had created an AVS VM pool. Let's create a new pool for AVS VM behind firewall pool, right? And we'll give it an IP, and we'll call it 10.100.32.10. That's our web VM, and we'll hit add. Let's quickly grab this front-end IP over here. And let's go through all of our settings. So we have the listener set up already. We will be using this listener, and we have a rule set up already. So in this rule, we'll go ahead and use the backend target as our new pool. Okay. And let's double check the backend health. And there we have the backend pool is healthy. And of course, there was one more setting that I missed showing you. So we also have, we showed you the listener, the backend target, and the backend HTTP settings. So in the backend HTTP setting, we're just probing port 80. And now that we have it, let's go ahead and run curl against this IP. So here we are. Well, let's give it a go. And there we have the web VM. So we also tested our inbound through Azure. So through the application gateway, this web VM is behind the application gateway through going through the firewall. Of course, you can also set up NAT on the firewall as well, but for now, we haven't done that. And for completeness, let's look at this flow end to end and what it looks like from the perspective of the web VM, specifically what the source looks like from the perspective of this VM. So if we go jump back on the NSX side, on the vCenter side, this is the inside web VM. And if we try to hit the public IP of the app gateway, which this is the public IP, you can see on the left-hand screen that the source IP it is coming from is 3.6 and 3.7, which are nothing but the IP addresses of the app gateway. App gateway being a layer 7 proxy, it initiates a new connection and it is coming from the app gateway subnet, which is 172.16.3 IP. And of course, for outbound from Azure, you cannot do it with this setting. In the future videos, when you toggle this first setting, and the one where you accept the default route from Azure, we can egress from Azure. But for now, our outbound egress point is through the NSX tier 1 into tier 0. Okay. So now let's look at the limitation of this design. So let's say that we add more segments. We had a web segment, we add an app and a DB segment. The east-west flows would look something like this, as you see in the pink flow over here. But there are some limitations with that design. So Victor, I'll let you talk through the limitations with this design.
Yeah, so there's really two main caveats with this particular design, and one of them is around, can this design scale? Now, for those of you that have experience with VMware, as of right now, so the moment of this recording, virtual machines inside of a VMware environment can only scale up to 10 network interface cards. That NVA is effectively a virtual machine, right? So that means it can only have 10 NICs. Now, if we look at how we're utilizing those NICs, there's one for northbound connectivity, there's one for management, and more than likely you're probably going to deploy these on a some sort of HSRP or heartbeat configuration from an active passive scenario. So that's 3 NICs off the bat that you're going to be using out of the 10. Now, the other use for those network interface cards are for your segments, southbound of that NVA. So in this case, we have just 3, right? So 3 plus 3 is 6. That means that we only have four more segments that we can expand into. And the limitation around that is really based on your requirements to define how many security zones you want to have inside of AVS. So with this particular design, you can only really have 10 segments. Sorry, you can only really have 7 segments, and that's it. So if you want to have an 8th one, you're gonna have to deploy another NVA, and then another NVA for another security zone. And as you can tell, that becomes very expensive, right? Because these NVAs, for example, you're using a Palo Alto appliance, you're gonna have to pay licensing for that appliance, right? So that's really the main downside. I typically only see customers do this on very flat networks. For example, virtual desktops. You're gonna have a virtual desktop farm inside of AVS. This use case or this architecture is perfect because more than likely you're not going to have more than 7 segments for all of your desktops. Okay. I think it'll probably be a good. We just talk about the other scenarios.
Advanced, yeah, it sets it up perfectly for our advanced scenarios. Yeah, so let's do that. This is the layer for the advanced scenario, and this is the same option that we talked about, Victor, but like you mentioned earlier with NVA, dual NVAs.
Yeah,
so that's just, yeah.
One of there's some sort of a virtual IP in here, and then there's a heartbeat, right? But basically, only one of them is the active one. But for this particular scenario, there's 3 interfaces being utilized: one for management, one for the uplinks, and one for the heartbeat. Right. So, and then here it just describes how many different tiers we have for our environment. Now, I think for most customers, this is probably not going to be a good architecture unless they're going to use virtual desktops or very flat layer 2 networks. Probably the most likely scenario is going to be the next architecture, which is how can I define multiple security zones and still scale at the same time? So in this case, you still deploy the NVAs. One NVA is one for one security zone, the other NVA is for the other security zone. So for example, what we have done in order to scale is southbound of that NVA, you connect an isolated tier 1. And basically it's a tier 1, and we call it isolated because it's not connected to a tier 0.
Yeah, exactly. So it's not connected to, yeah.
Yeah, so that tier 1 has a default route, has a quad 0, with the next hop being the NVA, right? And then that's how traffic gets out. And then the tier 1 on the top knows about the networks on the bottom because it also has a default route to that NVA. Now, what this allows you to do is that tier 1s are not...
You mean the web app DB routes to the NVA?
Yeah, correct. Yeah. Now, what this allows you to do is that tier 1s are not limited to 10 network interface cards, right? I believe they can have up to 1,000 interfaces. So you can have 1,000 segments hanging down from that tier 1, and that could be one security zone. For example, that could be the intra network. And then this, for example, this red segment or this red security zone could be your DB, or it could be your DMZ security zone. Right, and you can have multiple segments hanging out of that particular security zone, right? So this is probably the most popular use case for customers that want to mirror what they have on premises. And on premises, typically VMware environments have more than one security zone from a networking standpoint, right? And if you want to mirror that, this is probably what I will recommend: is have multiple tier one southbound of that NVA.
Awesome. Thanks, Victor. Yeah, so maybe we can just do for completeness, maybe just look at the flows on option one. The east-west flows, so from app to DB will go through the NVA, and of course we looked at all the north-south flows before. And Victor, is this, if the vendor supports this, can this be active? So in other words, can it be active, or is it with the notion of floating IP that it would be active, always active standby?
I typically always seen them active standby,
Mhm.
but I think that will be really up to the vendor.
Okay, and so that's the flows, and then just be aware of the static route. So here you would put a static route 00 via tier 1, and then on the tier 1 you would need routes for the web app and DB via the NVA,
Yep, correct.
right? And then likewise for option 2, again, it's not connected to tier 0, but let's look at all the routes end to end. You would need a 00 on this one to the NVA, 00 to tier 1, and then for the return traffic, you would need web app DB via this interface of the NVA,
Correct.
right? And then the flows east-west would go through tier 1 to NVA to this tier 1 to the blue VM. So that's this orange flow, and of course the north-south would flow through this path to this tier 1 and the NVA. Now there are two NVAs here, Victor. So again, it would just be it's this interface, right?
Yeah. That's fine. Sometimes customers bring multiple NVAs, not
Mm-hmm.
so much from a high availability perspective, but from a security zoning standpoint, right? So, for example, you'll be the NVA on the left might be used for one type of flow,
Mm-hmm.
and then the NVA on the right will be for another, maybe going out to the internet.
Got it. Yeah, so there's one more variation to the design. Is there anything else we missed on this one before we go to another variation of this design?
I think we cover most of it. Yeah.
Perfect. Okay. And there's a variation of this design where one of my customers needed dual tier 1 design. So let's look at that one. So let me light up this single tier 1. We've already seen this design. But what the requirement was that they needed another tier 1. So all of their internet bound traffic was going through tier 1, and private traffic was going through this corp tier 1. And then likewise, this NVA was for private traffic, and this NVA was for um, internet bound traffic. And of course, the inbound will also land on this tier 1.
Yeah, that's a very popular use case for traffic that needs to be inspected or deep packet inspected before it goes out into the internet. Yeah, so I like this design. It's very clean, right? So because you still have one tier bound southbound
Mhm.
for all of your segments, and then it splits off either if you're going to go to the intranet, it goes up to one set of NVAs, and if you're going to go out into the internet, it goes off
Mhm.
of another set of NVAs. So it's very easy to troubleshoot the flow.
Perfect. Yes, and Victor, one more question that I have personally. I tested this design before, but what I can't remember is if we have this toggle. So if we're using the portal setting of NSX, connect using public IP.
Hmm.
Could you use this entire, so let's say I have a /25, can I use one of the public IP on this tier one and one of the public IPs on this tier one? Not that it makes sense in this design, but just curious if we could split those public IPs across the tier one.
I guess technically you could. I don't see why you will want to do something like that. But yeah, I mean, I don't see why technically it wouldn't be possible. What I like about this particular design is that you will have the public IP on the right-hand tier one for north and south
Yes,
traffic, right?
yes.
And then everything else. So from a routing standpoint, that the inside segment tier one has a quad zero going out for the right-hand NVA for the 32.253,
Mhm.
and then it will have everything else on the RFC 1918 space going out into 10.100 at 32.254.
Yeah, and you brought up this is why I have a routing layer.
Oh,
Um,
perfect. See, we think alike.
so 00 via NVA2, RFC 1918 via NVA1, right?
Hmm.
And then, and if you had another discrete segments, you can also put, I have some other static routes if you had other segments, but they're not relevant in this picture. And then again on this NVA, you need 00 via this tier one, RFC 19 via this tier one. And then here is where you would put all of your DNAT, SNAT, as you saw in our previous scenario.
Hmm.
So with that, Victor, I was wondering to complete maybe this, we take a look at the network topology to see how it looks. Ready?
Yeah, let's look at it. Yeah.
So here, would we be able to see all the DNAT? Yeah, it's showing us all the 4 NAT rules.
Hmm. The 7 segments that are connected.
Where you see that? Oh, 7
Uh,
segments.
yeah,
Yes. Yeah.
right.
Okay. Yeah. And then we have a tier one. And so this is the previous design, of course, not the advanced scenario, but the previous design.
Yeah.
Okay. Awesome. And then one more thing is I wanted to create one additional tier one gateway. And I think in one of our previous videos, we reference how this appears in the Azure portal. So we'll just record that part here. So we'll say tier one, we'll call this internet. Let's call this internet tier one. And what should be the mode?
I think active standby should be fine for now. Yeah.
Okay.
There you go.
And we just do a save.
Oh, the edge cluster. Yeah, we only have one.
Okay.
And for those of you that don't know, typically when you deploy AVS, the default size is a 3-node cluster. And your edge cluster basically just means where am I going to put my edges and which hosts have uplinks to the outside world. And typically, in AVS, it's always your first cluster. So, for example, if I deploy 3 nodes on day one on cluster one, and then later on I decide to deploy another 16-node cluster, your node cluster is always going to be the first one. Okay.
Awesome. Thanks, Victor. Yeah, so let's go ahead and save this and then we'll see how that shows up on the Azure side. Mm, So this is my SDTC, and if we go under workload networking, segments, and if we when we try to add the segment, here, I think, Victor, you had referenced that we would not get a drop down for the second tier one. So is this what you wanted to check before?
Yes, exactly. Yeah. So in our previous video, sorry, it took me a while. Yes. So yeah, if you, this is one of the downsides of deploying segments inside of Azure, right? That it's always going to use the default tier one that it created. If you deploy another tier one, is the drop-down menu doesn't get updated.
Yeah, so
Uh,
for advanced scenarios, we need to use the NSX manager. So the last two scenarios that we showed, we would have to use the NSX manager to attach the segments, create the segments, and attach it to that tier one gateway.
Yeah, what I always tell customers is like think of the Azure portal for NSX operations as more of just deploying segments and letting your app developers just deploy segments as needed. But when you're gonna do things more advanced things like routing and do maybe things like VRFs and things of that sort, that's more of a network operator, network administrator, or architect role, and that should only be done by via NSX.
Yeah, great point. And lots of other knobs here as well, right? That we haven't explored, and one of them being load balancing, right? Is it supported in AVS? Could you comment on that, Victor?
Yeah, you can definitely do load balancing in AVS. You can, well, VMware has uh, its own solution for load balancing. That is called Avi Load Balancer. It probably got rebranded now that everything's part of the VCF. But it definitely, yeah, NSX has that capability.
Mhm.
It is an add-on, so it's not included with the licensing for AVS. And a lot of customers also what they do is they bring in their own third-party load balancers inside. So there's nothing that stops you from deploying a Net5 load balancer
Yeah,
or
and that's exactly, yeah, what
yeah.
I was going to say, that we have so far only covered firewall NVA. Yeah, so this video does not cover load balancing NVAs. The focus for this was firewalling and traffic inspection NVAs. So coming back to the big picture, and if you've been following along with me here, so far what we have covered is the scenario number 4, where we have NVA in AVS, and we looked at inbound and outbound unit using NSX-T Edge. We also looked at inbound and outbound using SNAT. So now we'll focus on this particular setting, which is accept default route from Azure. So either you do not connect or accept default route from Azure. So with this toggle, what happens is with the NVA ARS combination, we will advertise 00 down this way, and then we will egress using this NVA. Okay, so let's get started. So let's hide the big picture and light up the scenario for NVA in Azure. Okay, so remember that the toggle is connect using default route from Azure, or if we don't get the default route, do not connect. And we'll see that all in the portal as well. So let's go ahead and uh, do the envisioning first, and then we will look at the portal experience and jump on NSX Manager and vCenter and run all the validations at every point in the network. So as a starting point, we will have a workload segment. Notice the IP address range 10.111, and there is a VM there, which is 10.111.10, and we would have an NVA ARS combination, and the flows would look something like this. So from AVS to a spoke VM in Azure, the pink flow over here, we will be using, note that we will be using gateway subnet UDRs, and on the spoke subnet, spoke 1 subnet, we will have a 00 via NVA and don't propagate gateway routes. This is very important for flow symmetry. So gateway subnet UDR and don't propagate gateway routes setting on the route table, and I will show you all of this in the portal as well. And then we will also have VPN-ER Transit, the green flow over here, which also funnels through the NVA. So the idea is to have NVA as the inspection point. And next, let's hide these two flows. And the flow of interest is the north-south flow, this orange flow. So we will, the NVA will advertise default route down this way, and this VM over here in AVS will egress using the NVA. And then looking at all the flows together, we will have the orange flow, outbound, green flow, VPN-ER Transit. We will have this pink flow, AVS to Azure, and then of course this purple flow, which is spoke reaching out to the internet in Azure. Everything is now funneling through the NVA. So let's now jump onto the portal. So this is the SDDC. Note the overview page has all of the address blocks for the management networks. And then let's cycle through all of these tabs. The most important one being I already have an ExpressRoute connected here. So we have the key here, and I'll show it to you on the ExpressRoute gateway side as well. And then let's look at a segment. We have a workload segment that I have created, and I have 88CP server, and then DNS, just note the DNS IP over here is 10.100.0.192, and for internet connectivity, and this is the important setting right now, is connect using default route from Azure. So next, let's jump on to the vCenter and make observations over there. So here I am on the jump box from which I can access the vCenter and NSX Manager. So here notice that we have a workload segment, and I have one VM which I have called it Photon VM. So here I am on that VM, and let's look at let's make the observations here. So if I look at the IP address, its IP is 10.100.11.10. And then let's have a baseline ping test. So here, from here, I'll ping something in Azure. This is the VM in Azure, and this is the VM across the simulated on-prem. Okay, so we can ping those two. The important observation over here is if I do curl ifconfig.me, this fails. The reason is that we don't have default route advertised yet from Azure. Also note that there is a command to test if DNS is set up correctly over here. So let's take a quick look at that one as well. And here you could see that DNS is indeed set up correctly, but we just don't have the default route coming from Azure. So this is the starting point. And in the end, we will have this curl ifconfig.me egressing from the NVA in Azure. Okay, so now let's look at the NSX side. On the NSX side, we go to the networking tab and we can look at the segments, which we already have the workload segment here. And if you look at the tier 0, let's go ahead and look at the full route table over here. So we'll do a download route table. We'll do a before and an after. And right now, if you download the route table, let's take a quick look. You could see that here, if I do a control F and if I try to find 0.0.0.0.0, it cannot find the default route. However, I am sending 11.0 route, and let's go ahead and look for it. And there you could see that we are getting some routes from Azure, just not the default route yet. Okay. So this is a good trick if you are troubleshooting any routes coming from Azure. You could download the route table, and we'll look at it after we advertise the default route as well. So now let's jump on the Azure portal. So here I am in the Azure portal. Let's look at the ExpressRoute Gateway first, and we'll work our way through looking at it end to end. So this is the ExpressRoute Gateway tab. You can see that I have a connection to AVS to the Nihali SDDC here. And let's go look at the VPN gateway. On the VPN gateway, I have a VPN tunnel to the simulated on-prem, kind of jumping back over here. This is a simulated and on-prem, and I have an ASAV running over here. So this is the connection, and then let's take a quick look at the configuration just so we have all of the screens recorded. And here you could see that I have a VPN gateway queue here, and then connection. And if we go in the connection here and the configuration, you could see all of my phase 1 and phase 2 proposals. And then let's look at the local network gateway and configuration. And this is the 10.10.2 network, which is the on-prem network across from the tunnel. So this is this network. If I light up the IP layer, you can see that that's the 10.10.2 network that I have in the encryption domain. Then again, connection to ASAV. So that's on the VPN gateway side. If we take a quick look at the properties, you could see that it's an active VPN gateway with two public IPs. Now let's look at the route server. And on the route server, we have branch to branch toggle enabled. If we look at the overview screen, these are my route server IPs. And if I look at the peers, it peers with the NVA. Note the NVA IP is 25.4. Now let's look at the NVA. Currently, this is the effective routes on the NVA. The most important part over here is that on the NVA subnet, you need to ensure that the default route is set to internet. Otherwise, when we advertise the default route, it would loop to itself. So if I go under this route table, you will see that I have set the 00 via internet. This will come in at play when we advertise the default route. So there we have the effective route table, and then if you look at the overview screen, this is my IP address of the NVA. So we'll leave it at the effective route screen. Now let's look at our spoke VNet. The spoke VNet over here, this is the VNet in question. Let me hide all the flows. This is the VNet in question, spoke 1, and I'll show you this peering. And here I have the peering from spoke to the hub, and you will see that I have these settings, use remote gateway in the hub VNet. So that's the peering. And then if you look at the spoke VM, I do have a route table that says route via Bird. I'm using Bird as the BGP tool on the Linux NVA. And if I look at the route table over here, I'm using default route via the appliance. Okay, so that's the key over here. So if we look at the routes, and as you can see, I'm routing via network virtual appliance. In my case, I'm using the NVA, which is based on Linux, and it implements routing protocols like BGP and others. And the tool that I'm using is Bird BGP. Okay, and I'll show you that in the command line as well. So next, let's look at the gateway subnet UDRs. Like I mentioned, the gateway subnet does need UDRs to both the AVS routes, the VPN routes, and the spoke routes for everything to funnel through the NVA and stay symmetric. And you can see that I've associated with the gateway subnet. Now let's look at the spoke 1 VM. And spoke 1 VM, we'll run a few tests from the spoke 1 VM. Let's look at the IP address. It's 10.1.1.4. And from the spoke 1, likewise, we should be able to ping 10.100.11.10, which is the IP address of the VM in AVS. And we should also be able to ping 10.10.2.5, which is a VM across from the tunnel. And if we do curl ifconfig.me here, it is egressing using the Bird, the NVA IP. So let's take a quick look at the NVA IP over here. Is 131.27, the last two octets, and that's what it is egressing from. So far so good. So let's now jump on to the terminal and we'll make observations at every state of the network so we know how the routes look like. So on the left hand side here, I have a window on the ASAV. So if I do look at the VPN session DB on the ASAV, I have two tunnels because I have an active VPN gateway. And you can see that I have a static tunnel. So if I do show run route, I do have my routes going over the VPN gateway. Of course, these are the I'm only using one tunnel. So you could see that the 10-100 routes are getting routed over the tunnel. And here I am on a VM inside behind the firewall. So this is the VM that I am on, and I should be able to ping the AVS VM likewise, and I should be able to ping the VM in Azure, the spoke VM in Azure. Oops, should have been 10.1.1.4. Okay. So there we have the connectivity from the VPN connected branch. And let's look at the status of the bird. Like I mentioned, this is bird C is the daemon. If you are interested in knowing more about it, I'll put the link below. And let's run some commands over there to validate the status. So I will just start to run different commands. You can see it has established connectivity to the two route server IPs, and it also has the status is ready and going. And let's look at the advertised routes. So if we quickly look at the config here, you'll see that I'm advertising this route right here, the 11. just as a test route. I'm advertising this, and later we'll advertise this quad 0. But for now, you can just make the observations of the different route advertisement. So let's look at the one export for Route Server 2. And let's also look at what the route looks like for AVS. And you can see that we have learned the routes for AVS as well. So this is the perspective of the bird NVA. So now let's look at the routes at different levels on the Azure VPN gateway side, and ExpressRoute Gateway and ARS. So we'll start with ExpressRoute Gateway. We'll just capture the different state of the system. We'll list the learned routes. And as you can see above, these are the two peers. So O6 and O7 for the ExpressRoute Gateway. And these are the two, so this is the MSEEs, and these are the two route server IPs. So this is the list learned routes. And now let's look at the advertised routes. And we will now look at the advertised routes to the MSEE. And we should see that the big observation over here is we should see the 11, the test route that we have over here, being advertised down. And that was the route that we saw in the NSX tier 0 route table as well. Okay, so that is all the ExpressRoute Gateway's perspective. Let's take a quick look just for the completeness of the recording. We'll just quickly list all of the output for now. The VPN gateway. That's the VPN gateway's perspective. And then we'll look at the learned routes. And notice that all of the AVS routes are the 10100 routes. And now let's look at, lastly, let's look at the ARS perspective. So you can see ARS peers with the bird NVA. And here you can see that it has learned the 11 networks from the NVA side. So with that, let's go ahead and advertise the default route from the NVA. So we'll edit the config file, and we'll uncomment the default route, and we'll restart the bird daemon. And let's look at it again from the ExpressRoute Gateway's perspective to see if it is indeed advertising 00 downstream. And here you could see that we are advertising 00. So now let's jump back on to the NSX side. Before we didn't find 00. So let's dump the routing table again. This is a very good troubleshooting trick if you're not seeing the default route coming from Azure. So let's open. And we should see there, I could see it already, the default route. And we also see the 11 route that we were advertising before. And now the moment of truth, we go on the VM again and see if we can egress. So what we will do is we'll run our curl ifconfig.me again. And there we are egressing using the NVA IP 131.27, the last two octets. Let's double check that. And so here, if we go to the NVA 131.27, and if we absolutely want to be sure, what we could do is, let's do this. Let's go ahead and kick off a ping to 8.8.8.8, and we should see bidirectional traffic on the NVA. So if we dump packets over here, we should see bidirectional traffic, as you can see, 10.100, our source VM, which is in AVS, sending packets. It's the request packet and the reply packet as well. Okay, the reason we see the packets coming twice, it's a single NIC NVA, but you could see that both that the packets are traversing the NVA to go outbound. So again, back to the drawing board. So as you can see, the north-south now is egressing through the NVA, and you could see NVA is advertising the 00 all the way to tier 0, as we looked at in the tier 0 routing table. So with that, I'd like to thank everyone for joining. And Victor, thank you again for all the insights. Really enjoyed working with you. Lots of deep dives. And thank you for showing us all the different scenarios.
Oh, my pleasure. Always happy to be here.
Thanks, Victor. And this ends the session for NVA in AVS. Hope you enjoyed the session. Drop me a note, send me a comment, let me know if there's any other scenarios that you would like to be covered. With that, thank you again for watching, and we will see you in the next video.